In this presentation, I will talk about the analysis of variance methods. You'll find that in chapter 12 of your textbook. We covered the univariate two-sample mean test, where we tested hypothesis about two population means, and we tested that whether these two population means are equal or not. So for that, we used a t-test statistic. So I'm giving you a scenario here. For example, we have a research question that we want to know whether the population mean GPA of UNC and CSU students are the same. So for this, we have to draw random samples of students from each of these universities, and we have to calculate sample mean, and we have to perform a two-sample t-test. And the test statistic, as you are familiar, is presented here. And we know that the test statistic will follow a t-distribution with n1 plus n2 minus 2 degrees of freedom. So we calculate our test statistic, and then we compare that with the tabulated value of the t-distribution, or simply we calculate the p-value, and computer software will give us the p-values, and we will make a decision based on that. So this test statistic has an assumption that the population variances are the same, and that's why we pull or we combine the sample variances to get a common estimate of the population variance using the pooled sample variance. Now, t-test is okay for comparing two population means, but in many practical situations we would like to compare the population means of several populations, more than two. We want to modify the research question that we want to compare the GPA of more than two universities. Suppose we have we want to compare between three universities. Okay, so what statistical procedure can be used? In that case, we cannot use t-test, because t-test is applicable for comparing the two population means only. Now, the statistical procedure to do this is what we call the analysis of variance. So analysis of variance is simply called the ANOVA. So ANOVA is kind of an acronym of the analysis of variance. Okay, so analysis of variance, as the name suggests, it deals with analyzing the variability in the data. So what do we mean by that? We need to review the concept of variability. Okay, so let's review it. Analysis of variance is a tool, as we have mentioned already, for testing the equality of several population means. So remember that in a t-test we compared that the population means of two populations are the same against the alternative that they can be one can be greater than the other, lesser than the other, or just not equal. So in analysis of variance, we can compare more than two population means. Okay, so the research question would be, is there a difference between the GPAs of students of three universities, UNC, CSU, and UCLA? Again, we are just making this up, and we are creating a data set, a small data set with only 5 observations within each of these universities. So here's the sample GPA, and this one, suppose this column is for the students of UNC, and the second column is for CSU, and the third one is for the UCLA. Now, if you look at the data without looking at the column, for example, there is no, I've removed the column names from here. You see, now look at the entire data set. What do you see? Do you see that the numbers are different, right? So that is the important thing to notice here, because the numbers are different, meaning there is variability in the data, right? So that's very important, and we want to analyze the variability. We want to answer, we want to know why there is variability in the data, and what are the reasons, what are the factors that are causing the variability, what are the sources that are causing this variability. Okay, so that's the important thing. The numbers are different. Okay, the question is, why do they vary? Now, we want to answer this. The simplest answer would be the numbers vary because these numbers, the GPAs, are from different universities, right? So these numbers are from UNC students, these are from CSU, these are from UCLA, and we see these numbers vary. And obviously, we can automatically think that the numbers are varying because of the university factor, right? That's a single factor. Well, you might be thinking that the numbers are varying within UNC, within CSU, the numbers are not the same, so there is variability within each of these universities. And if you are asking this question to yourself, then that's really good. Indeed, the numbers within each of the university are different. And why they are different, we do not know. All you can say that there is random variation within the university, because we have only one factor, one source of variability overall, which is the university. Okay, so university is acting as a source of variation, and also there is another source within each of these university, and we'll talk more about that in a few minutes. So what ANOVA does, it deals with finding the significant sources of variation in the data. So it tries to find the sources of variation that is causing the variability in the data. It tries to identify the sources or the factors that causes the variation. Okay, so here we have only one such source, and that is the university. And for that source, we have we have three groups, and within each group we have only one measure, that's the GPA. So that's why it is a univariate analysis of variance, and you will learn more about that later on. So now statistically we want to formulate the hypothesis. So here we have three universities, that is we have three student populations, and we want to compare if the population means are the same, so mean GPAs are the same. So the hypothesis will be written in this form. So here we are hypothesizing that the population mean for the first population, the first group, the second group, and the third group, they are all the same, against the alternative hypothesis that at least one of them, which one we don't know yet, at least one of them will be different. In other words, you can say at least one pair will be different. It means the same. Okay, since we're comparing more than two population means, we cannot use a t-test here. The appropriate test is an f-test. What does the f-test statistic do? This test compares two types of variability. Basically, it calculates the ratio of two variations. So one is called the within group variability. Does that sound familiar with you? We talked about it in few minutes ago. Within group, there is variability within, and also it compares with the between group variability. Okay, so these are the two types of variability that are being compared in this test statistic. So the test statistic looks like this. It's a ratio of between group estimate of variability and within group estimate of variability. So like in a t-test, this test statistic has a probability distribution which is called an F distribution. Again, I'll not discuss the technical details of it, but just that F is calculated by taking the ratio of these two variabilities. Okay, now I'll explain a little bit more about the between and within group variability. All right, so again, recall the GPA example that we have three columns. We have three samples taken from each of these universities. A university is acting as a source of variation. We can see that. Now the question is, are all the numbers same as a whole? We answered this question, no, right? They are different. Are all these numbers same within each university? Within each university the numbers are different, so there is variability within each university as well as variability overall, right? Is there a difference in variability from university to university? Is there a variability that is different from UNC to CSU, from CSU to UCLA, from UNC to UCLA. And obviously, we can guess by looking at these numbers that yes, variability in UNC could be different, probably different from the variability of CSU and so on. Okay, so now if all the numbers are not the same within each university, then there exists variability within, right? That's called within group variability. So these are the three groups that we have, and this is within group variability, okay, because the numbers within each university are different. How do you calculate this? You calculate the same way we calculate variance. So we calculate the average of this group, and then we calculate the sum or the total of the squared deviations of each of the observations from the mean, and we do this for each of these group and we add them up. Okay, so this variability is due to the random variability, the random source of variation. Because it is variability within, we do not have any further information that why they are varying, so that's why we call them random variation. Okay, so this variability is due to random errors and not as a result of the university factor. How about variability within, variability between? Now look at that. There is variability from one group to another. The variability of one group is different from the variability of another group. That is called between group variability. Okay, how do we calculate this? We calculate overall mean, and then we calculate the variability by taking the sum of the square deviations of each of these observations from the overall mean. Okay, so that's how we calculate the between group variability. So the variability, the between group variability is the variability due to the university factor, right? We had talked about it. Now what is sum of squares? So we now know the variability is represented by calculated the sum or the total of the squared deviations from each of the observations from the group mean. In case we are calculating the within group variability, right, we are subtracting each of the observations from the group mean, or from the overall mean when we are calculating the between group variability, right? Okay, so we have between group sum of squares and within group sum of squares. So sum of squares is the total of the square deviations, and we call it sum of squares. Sometimes we denote it by SS. Okay, now the within group sum of squares, within group, remember within group is related to the random error, so the within group sum of squares is known as error sum of squares or sum of squares due to error. Okay, now let's take an example of the GPA data. Okay, so we have a small data set that we have introduced before. Now we are creating a SAS data set by this data statement that we are creating a GPA data set, and we are calling the data set GPA. We have two variables in this data set. One is the university, which is a categorical variable. That's why we have a $sign here, and then GPA is a numerical variable. And then we have to use these cards to enter the data. You see UNC, we have 5 observations for UNC, 5 observations for CSU, and 5 for UCLA. Put a semicolon and then run, then it will create the data set. So you can copy and paste it in your SAS and it will create the data set for you. Once you create the data set, let's first do a descriptive analysis, get some descriptive statistics, and we want the means procedure. So we have calculated the mean, standard deviation, and we are rounding the numbers to 2 decimal places only with this max decimal option. All right, here class is a statement to indicate that university is a categorical variable. It's not a numerical variable, and the GPA is the variable whose means are requested. So you will get a table like this, and that will tell you the mean GPA for CSU students are 3.38, UCLA 3.84, UNC 3.90. Right? From the sample mean, we see that there is not much variability between UCLA and UNC, but CSU is kind of different from the rest of the two. So it tells you something, right? That they are not equal. Okay. Again, we are not testing if the sample means are equal, but we are testing if the population means are equal, but we are using sample means for that. Okay, so now we want to carry out the analysis of variance procedure, and for that we'll use a general linear model framework in SAS, and this is called PROC-GLM. Okay, so PROC-GLM data is the GPA data that we want to use, and then we have to declare which is the class variable, which is the categorical variable, in this case the university, and then we have to write the model statement where the outcome variable is the GPA or the dependent variable, and the university as an independent variable. Okay, so once you run this, you will get a lot of output in the SAS output window, and for now in this course, for this topic, we are only interested in this table. This is the global ANOVA table. Okay, so the dependent variable is GPA, and you get a table like this with columns, sources, or in other words, sources of variability, and then the degrees of freedom, the sums of squares, and the mean squares, and F value and the P value. Okay, so the model as the source of variation is actually the sum of squares between. So between means the between group, the between university. Okay, and then the error is the sum of squares within. Okay, and these are the sum of squares that have been calculated from the data, and then the mean squares are basically you divide the sum of squares by the degrees of freedom. Okay, so how do we get the degrees of freedom for the model? It is one short of the number of the groups. So we have 3 groups here, 3 universities, so degrees of freedom is 3 minus 1, which is why it is 2, and then you divide the sum of squares by 2 and you get the mean squares, and then the residual sum of squares is obtained as a subtraction. Okay, so here the sum of squares for the residual is this, and we divide by these degrees of freedom to get the mean squares, and the F value is actually the ratio of these two. So this one divided by this one to get this test statistic value, and then it calculates the P value for us, which looks like very small. You know, we know that for a small value, for a small P value like this, we will decide to reject the null hypothesis. Now, how to make a decision from this ANOVA table? So recall that our null hypothesis is this, and the alternative is that at least one of the means is different, or at least one of the pairs are different. Okay, so here based on the p-value, we see that p-value is very small in our case compared to the nominal level of 0.05. Okay, so we have strong evidence to reject the null hypothesis. One thing I want to mention here though is that 0.05 is a guideline only. Okay, this is not something that you have to strictly follow, but 0.001 is really small, meaning that if the null hypothesis were true, the likelihood that we would observe a value of the test statistic that we have observed, which is this 13.39, if the null hypothesis were true, the chances is that it is 0.001. The chance is very poor, so suggesting that there is indeed difference between these means. Okay, so final conclusion, since we have evidence to reject the null hypothesis, so we are rejecting the hypothesis that all the population means are equal, right? So that's the hypothesis that we are rejecting. We conclude that not all the population mean GPA are the same, so there is a significant difference between at least 2 of them. Okay, so that's the conclusion. In ordinary simple per layman's term, so there exists statistically significant difference between the average GPAs of these 3 universities. All right, so that's how we conclude from this analysis of variance. Now, we have observed that there is a significant difference between the population average GPAs among these 3 universities. So a natural question is, which pair of means are statistically different, right? So they could all be different from each other. Maybe there is one population mean that is different from the others. We don't know yet. So the ANOVA test only tells you that there is a overall difference between them, but if you want to know which pair or which one of the population means is different, we have to carry out the so-called post hoc tests or post hoc procedures through multiple comparison. And Bonferroni's method and Tukey's method are two of the commonly used multiple comparison procedures, which you will learn in some other courses. So I hope you have a good understanding of variability and then and how we analyze the variability using the ANOVA technique, and how we make a conclusion when we test a hypothesis to compare more than two population means. Okay, one thing I want to mention here is that the ANOVA technique can be used for comparing two population means as well. Okay, so for comparing two population means, we typically use t-test, but this ANOVA technique can also be used as well in order to see the relationship between t and f-test. You will find that in your textbook. So that's all for now. In the next topic, we will discuss two-factor ANOVA. So if you have two sources of variability, how do we carry out the ANOVA test? Thank you.